So welcome back to our R session, and on this session we are going to discuss about box plot under statistical computing. We are going to discuss how we can generate the box plot in R. So I can have a comment here and say box plot. So basically a box plot shows the statistics of a data. A box plot will basically show the statistics of our data, in that it represents how well the data in the data set is distributed, and in so doing it will depicting the minimum value, the maximum, the medium, the first quartile and the third quartile of that given data set. So it is very important, the box plot, because it depicts the minimum value, the maximum value, the median, the first quartile, and the third quartile. And you realize in creating a box plot in R, we use the box plot function. So we are using the box plot function. Basically, that is the function we are going to use in plotting a box plot of a given data set. So suppose we have a data set, let's say we call that data set variable 1, that is var1. And here we are not just we are going to pick a random variable, a random data set, but that data set will be normal distributed. And we know when we want to have a normal data that is distributed normally, we need to have to specify the number of the data set, that is the n, the mean, and the standard deviation. So let's say our variable 1 is the data is the variable that has the data set that is normal distributed, having 100 set of elements, and it is having a mean, that is the mean of the elements is equals to 3, and let's say the standard deviation SD is equals to 3. So that is my variable 1 is the set of a normal data set having n entities as 100 and mean 3 and standard deviation 3. So I can even go ahead and call the selected data set, that is var1, and as you can see, this is the data set that will be selected randomly, but this data set is normal distributed with mean 3 and standard deviation 3. So we need to have a box plot. We need to generate a box plot of this data set and see the statistics of this data set, how the median, the mean, the standard deviation, the upper quartile and the lower quartile are distributed. So I'll go ahead and use the box plot function, box plot, and I'm plotting. What am I plotting? The variable 1, that is the name of the variable var1, and I can even label I can have a title at the top, that is the main title, and the main title I want it to be box plot. So I'll having my main title as a box plot, like that. Then I'll have my not each function, and in this case I'll say false. I'll talk about this. Basically, a not each function is a logical value that state how the medians of different groups match with each other. A not each function will tell is a logic value that states how the medians of different groups match with each other. That is, suppose I had 3 groups of a given data set, I'll be using the logic value not each to determine how the medians of the different groups match with each other. So maybe in the next example we'll be having a data set that has more than one variable, and with that we'll be use the not each to determine the the matching of the medians. Again, we can go ahead and have the var width, that is the width of the variable var width. And for this case, we have to say the value of the width is true. And now var width is a logical value that states whether to draw the width of the box proportionally to the sample size. The var width is a logic value to state whether we need to draw the box plot proportionally to the sample size. And yes, we need to draw it proportionally to the sample size. That is why we are having our var width as true. That is why we are having our var width as true. Again, we can go ahead and give a color to our box plot and say color equals to, and we can have our color as green. We can have our color as green, and with that we can have our box plot. Here is our box plot. We can see our box plot, and the box plot is used to determine the outliers. As you can see, we have an outlier here. One variable is well depicted here. So these are the minimum, the median, and the maximum value. They are all depicted on the box plot. So that is our box plot. We can go ahead and try what we were actually discussing, that suppose we have more than one data set. That is, we can draw a box plot with the not-each set as true to see if there is any matching in the median of the data set. As well, we can have the same here and try to set the not-each for true and see what is going to happen. Suppose we have the not-each here as true. You realize the median here, where the median here is well tried to be shown nicely, such that if we have any other box plot here, we can observe if there is any matching of the median. But we can as well do that. Suppose we have two variables or three variables. Let's say I have variable 1. Actually, we have already our variable 1. We have already identified our variable 1 like that. We can have a second variable, let's say variable 2, and now we say this variable 2 is also normal distributed, and it is having 100 elements, but now the mean is different from the first one. So the mean is equals to 2. It doesn't mean it should necessarily be different. Is equals to 2, and the standard deviation is also equals to 2. That is variable 2. Oh, sorry, there is an error here. It should be normal distributed, so this ought to be an O like that. And we have my variable 2. Then I can have my variable 3. Which is also normal distributed. So it is normal distributed. And yes, we have 100 elements. We have 100 elements with now the mean. We can say the mean is 1, and the standard deviation is 3. So I have 3 variables: variable 1, variable 2, variable 3. And yes, I want to generate a box plot of the 3 variables. Because of that, I need to have what we call a data frame. Basically, actually, we are going to discuss about data frames and lists in the next tutorial. Actually, a colleague is to discuss variables, lists and data frame. But basically, a data frame represent the collection of elements that are of the same size. And we have those elements as a unit. So I'm going to create a data frame, and I'll call data frame that data frame data. So the data is equals to data dot frame. We will discuss data frame in the next tutorial. Don't have to worry about that. But here I'll majorly